Oh, yes. Yeah. Hey, Anton.
Hi, Clive.
Hi, Franz. I've seen you for a while, Anton.
Hi, Seth.
Yeah, I've been working on my ninja skills.
Your ninja skills. Wow. Yeah, that sounds like warfare.
I'm a much friendlier ninja than that.
Yeah, they're making things happen kind of skills. Is that it? Yeah. Hi, Sev.
Hi there.
Yeah. Now, thank you for
Anton has
your.
also been active in other areas, though. I've seen his name appearing a number of times.
I cannot confirm or deny.
You on some kind of campaign trail this evening with us, Anton?
No, I just I got a couple talks coming up and
That's
stuff
fine.
going on.
Whatever it is, if
Yeah,
you just want to let us know about something, that's all good.
sure.
Yeah. Now I'm just looking here. Sev, you had a suggestion, Sev, which I've
I've got
uh,
a
uh,
couple of things I'd like to do.
yeah.
I'd first of all like to update you, some of you who haven't heard, on the Buoyant flakes situation, which is
Right.
looking rather good.
Oh, great.
And
Yeah.
then I'd like to seek feedback on that email I sent out just yesterday, dealing with the um, ISA Aerostat method and uh, some of the extra work I've put into it.
Right. So, um, well, good. Let's start putting that in, actually. Let's make the use of our time.
So Buoyant flakes update and um, ISA Aerostat feedback.
Yeah, I think I've made a kind of promise to myself. Well, I think I'd make a promise to everyone that I'm going to get through. I'm going to manage the time better today. Because the last two meetings, I've missed things that people had. So let's quickly do this. Um, um, extend. Right. So then some of this stuff can go. Oh, it's working now. So now it's going to go. I have to say keep. You've got to get that. Yeah. So yeah. Right. So yeah, Sev.
Buoyant flake update. And please let me know if I've told you this before. It's hard
Yeah,
juggling
yeah.
all the boys.
Don't worry. Yeah.
And Sev again, so feedback on the ISA Aerostat um, um, advances, method advances. Yep.
Aerostat method advances that.
Yeah.
Yeah, fits on line. Okay. Hmm. Okay. Righto. Okay. It seems a bit boring for me to say we're working on ammonium sulfate aerosol because we're always working on ammonium sulfate aerosol. There's no, well, this it's not enough time to give an update. Right. So, hi, Ursula.
Hi,
Lovely to
hi,
see you.
how are you?
Well, very well, thanks.
Good.
Very well.
Good to be here.
All the better for seeing you, Ursula. We love to have
Likewise.
women. Yes, we love to have women. As I said, it just feels a bit suspicious if it's only men. Is it really about the climate or is it about some sort of men's shed gathering or something like that? Um,
Secret men's business.
exactly. Yes. No, it's dishonest somehow. So you keep us honest, Ursula. So please pitch in. Uh,
Will do.
yeah.
Thank you.
Right. And
Great to be here.
okay, Robert Tulip, please. Hi, Robert.
I'd like to talk about insurance.
Robert T. Insurance. Uh, what about it, Robert? Just insurance? Can you expand a bit?
Uh, that's enough for the agenda.
Insurance. Okay, all right. I know you know what you mean, and so we'll wait until to find out more about that. Okay. Anyone else?
Yeah, I'll do a quick update.
Yeah, yeah, yeah. So, Anton, quick update. So, can you say anything about what? What about?
Ocean fertilization.
Right. Yeah. Fertilization. Yeah. I'll just say update. We know it's going to be a quick update. Actually, I'll say let's put a quick update. Right. Because this goes into various summaries and things. So, if someone's looking for something. Yeah. Okay. Is this
Still
an
looking
update
at
for
nutrient upwelling, Anton?
beg your pardon?
Still looking at nutrient upwelling devices. We looked at that a few years ago, remember?
Is that what you're looking at,
Control
Anton? Nutrient upwelling?
Are you asking me, John?
Yes, Anton, yeah.
Oh, sorry. There's a guy
Sorry.
outside mowing the lawn, so I'm having a hard time hearing. Tangentially, I would say tangentially, yeah.
Yeah, right. Because this is something you've been working on for many years. Ocean fertilization. Yeah.
I have built a prototype of a mobile artificial upweller. Yes,
Yeah. Right.
built and tested. Yeah.
And tested. Yeah. And you're a mechanical engineer, so
Yeah.
hands-on guy. Yeah.
Has anyone got any word on the heating event we're about to see in the Pacific?
El Nino.
Yeah.
No.
I don't know more than what's in the media, but I wonder if anyone else had thought about what's going to happen, how to avoid it, how to measure it.
No.
No,
No,
okay.
we're reliant on the media. Right, there's three. May I hazard one more? One more thing? If not, we'll just expand. These will just expand. Maybe people don't. Yeah. So once again, I have failed the last two of these to get through all the agenda. What was on your list last time, Seb? I think it was yours that we missed. Do you remember?
Yeah.
It was a barrier reef, wasn't it?
Yeah.
Yeah, let's put that. Otherwise, it's
the buoyant flake one will do that.
well. Okay. Let's get started. We can always finish early, can't we? That's always the thought. So, yep. So that's you then, Sev, please. Buoyant flake.
Okay. Well, my Marine Biomass Regeneration Consortium with the 5 research groups had a quarterly meeting just a few days ago, and University of Southern California has made some major advances on the political side. They've convinced the Tongan Prime Minister, his cabinet, and most of their scientific staff to do tests with buoyant flakes, and then later on experiments and sea trials in their national waters. They have got interest by the Japanese government in the potential of buoyant flakes for providing carbon offsets, and if that goes ahead and the tests prove well, the Japanese may well fund the entire program, which sounds wonderful. It's as good as what we're doing off the Great Barrier Reef with MCB in my mind, and indeed it could even go faster than that. I've improved the flake formula because it was realized that the husk, when it was coated with 3 layers of mineral, wouldn't easily release silica, opaline silica. So all we did was to say, well, okay, let's put some rice husks through a ball mill, grind them down to a powder, and then include that powder on the outside of the husks, of the flakes. And that way we can give an immediate boost of silica and a little bit of phosphate to the waters of the Pacific, in particular those waters being researched by the University of Hawaii at Manoa, and that will allow the diatoms, the large diatoms, which are the preferred species for fish food and carbon sequestration and a whole lot of things, to get a jump over the tiny ones, over the blue-green algae and things like that. And it'll be particularly useful for that new diatom species which the Hawaiians identified, which have got endosymbionts, which are nitrogen fixing ones. That means that any nitrogen which they make from the dissolved air, there's no waste. It's already in their bodies. And therefore, when you first put out the flakes, you'll get, it takes about 3 or 4 weeks before the very, very few species in those oligotrophic waters flourish up enough to be seen. But after the 4th week, you suddenly see a wonderful greening occurring in these big cardboard bottles which they've been testing. And this will mean that we can get the better results faster by giving an advantage, just a temporary advantage, to these large diatoms. Now, the Hawaiians and the others have also been measuring the amount of chlorophyll which is produced in these cardboard bottles by the buoyant flakes they drop in them. Only between 1 and 3 flakes per large carboy. And so
what's a carboid? What's a carboid?
A large bottle.
Very large bottle. Got it. Okay.
And with when you've got chlorophyll measurements, alpha chlorophyll measurements, I would have thought that it wouldn't be all that difficult to translate that green coloration into additional albedo. And if they can do that in these small tests and then in the small sea trials, they would be able to give to Rob Tulip and other people, saying, okay, if we use the buoyant flakes, we can get, so many watts per square meter of extra sunlight radiation from off the ocean which we fertilized, and that could be a very substantial amount in my mind, as well as having benefits from the DMS, which the extra phytoplankton give, and the possibility of carbon sequestration. So that, to me, it's the first time we've had any national government give support to buoyant flakes. We've got the science of the 5 members of the consortium, and 2 of them which are from the global south, and this whole thing could be almost run by the small island nations. They would be in the box seat for doing a lot of little experiments in a lot of places, refining it, governing it from their own national governments, telling other people what worked, what didn't work, what balance of nutrients there were, how long the flakes lasted, all those sorts of things. And that is a possible way whereby we could get a sort of a groundswell occurring without having to have international treaties and that. So it could be sort of growing like topsy. And that to me was a superb result of what the team had done. Any questions?
Well, congratulations, Sev.
Well, it wasn't me. It was with the University of Southern California.
Yeah. Okay, but you've hung in there. Greg, please. Greg Slater.
Lots of questions.
You're muted, Greg. If you're speaking, we can't hear you. Greg, we'll have to move on. All right, let's go to. Yeah, are you speaking, Greg?
Yeah, I didn't know I was being called on.
Yeah, I said Greg. Yeah.
Yeah. Okay. So yeah, thanks for that. Just a couple of questions on the organizations you're working with. The work was you mentioned a collaboration with UCSC and
USC,
also the University of Hawaii at Manoa. Those they're both participants in this. Also,
yes.
Also, you the consortium you mentioned, a 5-member consortium.
Yeah, there's the University of Cambridge.
Yeah.
There's the University of Cape Town, and there's the National Institute of Oceanography in India. Those are the members of the consortium. They're trying to get on board the University of the South Pacific in Fiji, but I haven't heard of any outcome of that yet.
Okay.
So
it's yeah. Do you have do they have a website or anything where I can learn more about their work?
At the moment, they haven't published. They've got. I've read some of the pre-publication stuff, but as I'm a member of the consortium, also, sort of by grace and favour, I can't let a great deal out until they've got peer-reviewed academic publications, or at least put it out for a preprint for it.
I guess I
mustn't.
Yeah, I'm not asking you to disclose anything you can't, but I just in a general website where it discusses in a very general way what their goals are and what their funding, things like that, just to get an idea of more of a general sense of the work they're doing. I'm trying to get a handle on all the methods that are going on and where they are just generally as a private project.
Yeah, they don't have an individual one for the consortium. It was started by Sir David King at Cambridge, and there's been a few mentions of it on some of the Cambridge stuff, but not otherwise. They're at the moment, they're needing more fund. They're looking for more funding at the moment, but they are still beginning to continue on the work.
Yeah,
so I'm
okay.
sorry.
That's fine. I understand. And then the one government, the first national government that you said this is Japan. That the first case.
No, Tonga.
Oh, I'm sorry. Why? I don't know why I heard that.
Well, the Japanese may end up funding it if the experiments go well.
Okay, but it's Tonga.
Government of Tonga. Prime Minister of Tonga is personally fully on board with it, and at least some of his ministers and most of their scientific folks, and they've been visits and things like that, and they're now about to do tests.
Okay, I know there are others want to ask a question, but in terms of increasing albedo using the green color of the what is produced, I mean, I put
that suggestion out. They haven't had a chance to talk about it themselves and say it.
It could go either way, though, depending on if it's dark or light or reflective or absorptive. Is that right? I mean, I don't know.
Oh no! If you're going to make more algae in almost every ocean, it's going to brighten the surface of it. Okay. Because it's so much brighter than the dark blue deep ocean.
Okay. Thank you.
All right. Thanks, Greg. Thanks, Greg. Robert Tulip, please.
Well, congratulations, Seb. I think it's excellent progress. I've just been astonished that it's been so slow with buoyant flakes, because it's such a elegant and simple concept in terms of a circular economy waste management concept, and like the idea of using mine tailings and rice husks, which are otherwise largely worthless waste products, as a combining them as an essential ocean fertilizer is an excellent idea, and there's just a sort of toxic barrier to fertilizing the ocean due to the politics of climate change. It seems that has prevented the investment that's needed. I had actually a very good meeting with the High Commissioner from the Kingdom of Tonga in Canberra a couple of years ago, but just in general about the marine cloud brightening, and they were initially receptive, but then gave me the cold shoulder, and I think that that's a significant risk in this whole space because of the power of silent influence, and I would hope that the buoyant flakes would not be subject to this problem, but then I think some of the issues that come up with buoyant flakes include the potential interest of the fishing industry in improved yields as a result of buoyant flakes. And then there's also the whole combination with nanobubbles question. And is the nanobubbles aspect part of the research agenda?
No, not yet. No, it's only on ocean fertilization.
Yeah. All right. Well, well done, Seb. I just wanted to make that comment. Thank you.
Thank you, Robert. Can you just tell us, just summarize briefly, Seb, buoyant flakes, they last a year. And can you just remind us what they're made of again? It's sort of mine tailings and things, isn't it?
Yeah. They provide iron, opaline silica, and a small amount of phosphate. The iron comes from the red mud tailings from aluminium refining. The phosphate comes from phosphate processing, and they can't get out the last 15% of the phosphate to make phosphoric acid and DAP and whatever, because it's too tightly bound. But it won't be too tightly bound when it's on a flake exposed to UV sunlight and attacks by phytoplankton and other things. So those are the minerals, and they're all bound together by lignin, which you can get from things like straw and wood and whatever. It's once you've taken the sugars out of, say, straw, you're left with lignin powder, and so that's a hot melt glue. And if you can make the flakes, if you can make them raise with a leavening agent such as urea, which happens to dissociate at about the temperature which lignin melts, you don't want it to go too differently, then they should last for about a year. Just little tiny flakes on the ocean, you couldn't see them, but hopefully after several weeks you would be able to see a slightly greener tinge to that part of the ocean where the flakes have moved to.
Didn't you say they'd be like cornflakes?
A rice husk is the size of a rice grain.
Yes. And but when you've coated it with 3 or 4 or so layers of mineral and powdered rice husks, they might be twice the size.
Okay. And what's the rough cost then to put buoyant flakes on a, I don't know, 100 meters squared of ocean? You've got a rough
Well,
idea.
you'd probably need you'd need a less than a small handful of rice of flakes for that, because they're very, very sparsely thing, and you're making them the iron should be actually the mining company should pay you to remove their red mud tailings because it costs them to remediate the land and look after thereafter. Likewise with the phosphatic clay wastes, at the moment it's cluttering up, for instance, large parts of Florida with gluggy clay, which you can't use the land for anything else. And if you can use that clay, then the land becomes available for golf courses or whatever.
Yeah.
The lignin is the most expensive part of it, but if you're extracting, for instance, the sugars from rice straw and wheat straw to turn into, for instance, to use in precision fermentation, then that extra large amount of lignin is available for other purposes. Now, lignin is useful for some other things, but not at that,
On that scale.
50 million tonnes per year rate. And anyway, you could use any straw or indeed any woody waste for it. So the amount of lignin in the world is
Not in short supply.
20% of the woody or cereal biomass. That's an awful lot of stuff.
Yeah.
So do you have an estimated cost per square kilometre per year?
I haven't done that. It depends very much on how you bake the flakes. I'm proposing using a lot of renewable energy to dry them out and then bake them and things like that. I've worked out. I've done quite a lot. If you go to the NOAC website, you'll see a lot of documents on some of the costings, but I haven't worked out how much per square kilometre at the moment. But in a sense, I don't have to, because if you're going to be getting fishing royalties and maybe cooling credits or any other kind of stuff, it's probably going to be a profitable operation. So I don't care how much it costs. If it's profitable, it doesn't matter. Industry will do it.
Yeah. I can't. I've got it here right now, and trying to. So there. So there's the NOAC website, noac.info, and I thought this had a way of going. You could click into it. You could check, but maybe I'm not logged in or something.
You got to go into. I think you go into methods.
I think I have to log in. Let's try and see if it'll still log me in. So
yeah,
there we go. Methods.
Try methods and see if.
Right. Buoyant flakes. There we go. Buoyant flakes.
Now view the references.
View. Yeah, there's a whole lot of stuff here.
Those are all. Scroll right down. A lot of references.
Tons of. Okay.
And some of them deal with cost.
Yeah. Scientific engineering. Okay. Yeah. Okay. Great. Okay. Thank you.
Clive, on that point, is this? Do I need a password to get into the site?
I think you have to. No. Well, you generate one. So.
Okay.
No, you actually, I think you have to ask permission. I forgot. It's been a long time.
Oh. Okay.
So if you have a problem, Greg, just email me. I'll let you in.
Okay. Thank you.
Yeah. Okay. That's a simple answer. Yeah. Great. People know how to get in touch with NOAC. Sorry, Franz, you've been waiting a long time. Franz, please.
It would be interesting the pH looking at the pH when the greening comes and the diatoms develop, what kind of pH is developing?
Well, you
because
should be, you're converting dissolved carbon dioxide in the surface waters into biomass and oxygen. So the pH should increase slightly, which is good.
this is of interest. You said the diatoms develop organic bound nitrogen.
Yes, they've got endosymbionts living inside them, which transform dissolved nitrogen into nitrate.
And into nitrate, not into ammonia.
I'm not sure of it may well go through an ammonia phase.
Because, we are, our process we are working now with is the natural development emission of ammonia from the oceans in pre-industrial times. We say it must have been much larger than present,
This will
because
have
of
been
the many animals and so on which lived in the ferric zone.
Yeah.
And if you bring additional nitrogen by your process, this could also induce additional emission of ammonia, and such making ammonia sulfate particles as CCNs for white cloud for brightening.
Fish emit urine, which transforms into ammonia after a while. So that is one way which would happen. Fish eat the diatoms and then pee.
Okay.
Yeah.
Thank you very much. Very good.
Thank you, Franz. Anton, please.
Yeah, so just a couple quick questions. When you're thinking about albedo impacts, are you talking about from the flakes themselves? Are you talking about the phytoplankton biomass, or are you talking about it? What about DMS?
The flakes are negligible because there's only one flake per square meter or whatever. But it's the phytoplankton growing from them.
Got it. And then are you doing any calculations on DMS production, assuming that the chain of events from diazotrophs through diatoms works?
I don't have the science to do that, or the models to do that. The models should be able to tell you if you double the amount of phytoplankton in the ocean, they should be able to tell you how much you get.
Yeah, I'll circle back to that during my update. One more question on this, and Clive hit on it. Sort of a time release of nutrients. Do you have any sense of the intuitive sense or any data around the time release of the buoyant flake formulation as the nutrients get dispersed?
Yes, we do. The consortium has already done a lot of studies on that, on both release of silica and of iron, and both are looking really good. The opaline silica is particularly good because, ordinary silica like sand doesn't dissolve too easily, but opaline silica dissolves much more easily, and they've shown that within 2 or 3 weeks, you've got a very substantial addition to silica, and with a little bit longer, you've got release of iron. So that both of them are released at useful rates.
Okay. So I know Seth John and those folks are looking at diazotroph nitrogen fixers and the mid-latitudes. There are a lot of other scientists looking at those areas and looking at those processes. But I couldn't help but think about HNLC regions, which are more polar, that could also use the buoyant flakes, but for a slightly different stage. It could
They want
work
the
at,
iron.
That's high
yeah,
nitrate,
what it,
low chlorophyll, isn't it? High nitrate, low
yeah.
chlorophyll, but low in
So
other
in a time
micronutrients.
release, yeah, in a time release setting, buoyant flakes could serve as a secondary or tertiary dosing, which might make it advantageous and more economical in those regions, because if they do the original dosing with some other formulation and some other methodology, and at the same time they release buoyant flakes, which take time to do their release, it would line up potentially really well with either secondary or tertiary nutrient release needs to enhance blooms. And that might be another way in which buoyant flakes could become valuable.
I would actually say it could be the primary method.
Oh, good.
You
Okay.
you can it depends on the formulation. You change your formulation for whichever ocean you're doing it in, and for those southern waters, you'd have much more iron near the surface. I think they are also deficient in silica there, so silica and iron. They aren't so deficient, I think, in phosphate, so you wouldn't put so much phosphate in it.
Cool. Awesome. Thank you, sir. Appreciate it.
Thanks, Anton. John Macdonald, please.
Well done with this progress, Sev. You mentioned the University of South Pacific. You're working with Professor Anton A. He's a real expert in the blue economy stuff, seaweeds, and really.
We're not. The consortium, I've been told, have approached the University of the South Pacific. They haven't yet convinced them, maybe because they haven't been able to give them funding to join, but they're certainly trying to do that.
I had a number of discussions with him a few years ago. I'll send you his details. He's a very interesting fellow.
Good.
He's really an expert in that area.
Yeah, excellent.
Okay. Thanks.
Yeah, John and I met Anton through the Ocean Foresters group.
That's right.
And
Yes.
Foresters group would potentially be another interesting partner. I haven't heard anything from them for a few years now, so
No.
that's worth contacting. I just had one further question, Sev. You mentioned fisheries royalties. Have you made any progress on developing a governance framework for that?
All I've done is to, in some of those documents which the NOAC website's got, is to show what it would cost to disseminate to make and disseminate the flakes estimates, and the amount of phytoplankton and fish biomass which you should be able to derive from those additional nutrients. That's about all I've done.
Yeah, because it's got a significant potential as a profitable commercial industry.
Yeah.
And
yep.
And the there's a hypothecation aspect to improved yields from fertilizer, but it's a blue green revolution. Like the Norman Borlaug green revolution for cereals, there's such massive biomass, protein, albedo benefits from buoyant flakes. I'm quite convinced that these sorts of technologies are going to quite rapidly become major industries once the political blockages are defeated.
Yep.
Yeah. I guess to David King sounds like it's his contacts. He's been having some conversations, and something's come out of that. And as
yes.
He comes with a global sort of reputation as a respected kind of, he was a diplomat, wasn't he, and scientist and proponent of climate action, radical climate action to avoid disaster. Yeah, and so one step at a time. So I think it's get things happening first, and then I think yes, we'd be wanting to, hoping for positive, news stories, not negative ones. I've just got one more question. What I'm interested in, Seb, is experiments in deep water. We know this story that the US Navy once, when they first used their sonar, it looked like the whole seabed was coming up towards the ship. And it was just enormous amounts of zooplankton coming up.
And squid.
And squid, was it? Right. Migrating up to the surface during the night, which is what they do every night. So I'd be interested if they could is there any chance that they'd measure that, do you think? To measure the amount of the change of zooplankton migrating given the food at the surface, the new food at the surface.
How would they? Some of these ocean-borne sensors would do that. The PACE satellites will tell you how much and which species of phytoplankton are in the surface waters, which is one good thing. Copepods and other things like that. Unfortunately, as they come up at night, the satellite imaging isn't very good at night on the colour of the ocean, so it would be hard to tell with the zooplankton coming up, but you should be able to tell from the amount of from samples of the water taken.
Right. Yeah. So because it seems to me that you're providing some seed fertilization at the surface. There's an enormous amount of nutrients. I mean, basically you're supplying nutrients that are missing, which are often missing, or in very low supply. As you said, oligotropic trophic waters, which means virtually no nutrients or something missing. And but there's an enormous amount of nutrients a little bit further down, only usually about 100 meters or so, isn't it? So it's so near but so far.
And the bodies of those zooplankton will take up some of that water with them, either in their guts or by excretion or whatever. So yes, it would help. It would help bring up nutrients from the deep, as well as taking some out because they eat at the surface and then defecate down below. So a bit of both, but the whales would help.
Yeah. So to me, it'd be interesting to see what's the multiplier effect. That once it's there and once the buoyant flakes have been active at the surface and cause a result, or even that how much of that increase in biomass you could measure. If you know the increase in biomass, well, hang on, we only put in whatever, per 100 square meters, a kilogram of nutrients, and yet we've got an increased biomass of whatever 10 kilograms, in the same area. So certain amount must have come up from lower waters. So you could that could be a selling point that you only put this amount there, and the rest comes from natural migration, natural ecosystem.
Well, we do know that the biosphere hundreds of years ago was much more effective at moving nutrients around. So yes.
Yeah, we do. It'd be good to measure it and to know by how much and after how long, and because things always come down to cost. Okay, thank you very much, Sev. That's wonderful. All right, we've had half our time, and so where are we?
We're going to my second bit.
Oh, your second bit. Well, okay. Keep it reasonably short then, please. Feedback on ISA Aerostat method advances.
Right. Well, this 2-page thing, which I sent round yesterday, gives you what it is. What I was needing to do was to find out what bio oil was suitable to go up and to help volatilize the ferric chloride. And that's quite a difficult thing to do, because ferric chloride reacts with many things. So eventually, I came down to working out that if you use glycerol, which is glycerine, we knew as kids, that's very plentiful and very cheap at the moment because it's a byproduct of biodiesel production, and is also a very good fuel, clean burning fuel, because it's got oxygen in it already. But glycerol itself is too viscous, so you need to have something added to it to make it less so. And methanol will do that. Methanol is also fairly cheap. But what you've got to keep away from the ferric chloride is any amount of water. You've got to try and have, you need anhydrous ferric chloride, you need to have glycerol, which has been dewatered, and methanol, which has been dewatered. But putting them all together, you should end up with an economical bio-oil to help flare the ferric chloride into 30 nanometer diameter aerosols. And from that, we know we're going to get a lot of methane and nasties oxidized out of the air. And we're also going to have those CCNs of the ferric chloride eventually forming marine cloud. And I'm suggesting that if it was released at Tonga and Fiji, we could probably make most of the Coral Sea much more clouded over than it is. And if we do that, we cool that ocean and we cool most of the reef, which would be nice. And then finally, when those marine clouds turn into rain-bearing clouds, if it's over the ocean, you're going to have whatever ferric chloride is there raining down to the surface of the ocean and helping the phytoplankton. So win-win-win.
Yep. Great stuff.
The final thing in this is I've suggested that these bases for releasing the ferric chloride could also be multifunction bases for using the same wind turbines to release nanobubbles, cedomizer notionally, and a whole lot of other good things. And these could be based mainly on small islands scattered around the world, manned by islanders or maintenance staffs, and using wind turbines anchored in the shallow waters near to the islands. So you might be able to have a single island base, let's say off Hawaii, which is doing many of my climate restoration things all at once.
Okay.
So have a look at that, and please give us your questions and feedback in slow time. That's all. Thanks.
Okay, great. Thank you very much, Sev. Yeah, we need to have a look at that. Okay, so Robert, Tulip, please, insurance.
Yeah, thanks. So this Thursday, Friday, we have Sandy Trust from the Institute of Actuaries in the UK as the guest presenter at HPAC. And so Sandy is a lead author on the series of 4 reports that the Institute has published in collaboration with scientists at Exeter University. And so it's a good opportunity to discuss the relationship between the insurance industry and climate change. And we have a small group which Sev is a member of, and also Dennis Garrity and Brian Cady, myself, and John Macdonald had some association looking at insurance for HPAC, and we met with Sandy Trust and his colleague Oliver Bettis in the UK Institute of Actuaries, and discussed the whole question of the potential of the insurance industry to engage on climate policy. And it's a really interesting question in my view. It's a key theme in my forthcoming book on sunlight reflection, because my view is that the key to mobilising resources for sunlight protection will be engaging the commercial industries who stand to lose profit from as a result of heat. And so the primary industries there include insurance and tourism and agriculture and others. And but part of the problem that we've identified with the insurance industry is that they have. It's been asserted that they have a perverse incentive to not worry about climate change, because they are highly profitable in the context of worsening climate damage. So the reinsurance industry has estimated that the insurance bill from global warming is over $100 billion a year, and expected to double each decade. Now, the problem being that the culture and incentives of the insurance industry are very aggressively short-term, and so while they are profitable, they are not concerned about medium-term analysis. So it's no concern to them that large regions of the earth are becoming uninsurable because they can simply refuse cover and not worry. So there is a broader moral and political interest in making sure that currently inhabited cities and regions remain insurable, but the ability of to get the insurance industry to recognise that seems to be quite a challenge. So anyway, I just wanted to just give that quick overview and see if there's any comment on those issues. And there's this question of how to best engage the insurance industry. Now, Oliver Bettis, who joined us from the Actuaries Institute, commented that the actuarial profession has quite different incentives from the insurance profession, in that their understanding of the risk analysis arising from insurance concern is more medium term rather than short term. And so hopefully we'll be able to get the actuarial industry to engage with sunlight reflection. It is always perplexing to me that people are so standoffish about sunlight reflection as a concept and technology. So the partners who the Actuarial Institute have in the climate scorpion reports and etc., the latest one, the Parasol Lost, they appear to be resolutely opposed to sunlight reflection based on, for example, the Exeter University conference on tipping points. I think it was either last year or the year before. And so a number of people commented that, in particular Paul Gamble, that he tried to get the tipping point community to engage on sunlight reflection and was essentially given the cold shoulder. So those are issues relating to insurance, and I'll pass over to John Macdonald, who's got his hand up.
Thank you.
Yeah, look, it'd be terrific to, as you're doing, getting these people like this in the insurance industry and actuaries to join these calls, to bring them in on the discussion. You could make the point that the insurance industry is a bit like politics, with short-term election cycles as well. I mean, the focus is always short-term with politics as well. There's a parallel there that you could expand on perhaps. But if we can get them on board, it's a massive, massive win, isn't it? So good work.
Well, what I'm calling for them to do is to just provide a seed funding for a lobby group on sunlight reflection, and the point being that if the affected industries can just fund some of the advocacy research, then that can lead to a first mover coalition of affected nations. And so I was really pleased to hear Seb's comment on the potential of Tonga to take an interest in buoyant flakes. If Pacific Island, like at the moment, there is such a well-funded and aggressive lobby group who are pro-darkening, which led by NGOs and the Non-Use Coalition. And so, I prefer to refer to them as a pro-darkening coalition, because that essentially shows the agenda that they're putting out, and puts their work into the negative light that it deserves. There's nothing that's funding pro-brightening, and so. And yet there are big industries such as insurance who face a massive commercial hit. Sev and Anton have their hands up.
Apart from the actual benefits, there's a real geopolitical opportunity in engaging with South Pacific Islands that Australia and US other countries could lead as well.
True. Yeah. Thanks, John.
And you could also say, Robert, they're not pro-rebrightening either. They're not even pro keeping it the same.
Well, and I think that, Clive, that relates to an issue I've recently mentioned, which is we've been talking about albedo enhancement, but really the agenda is albedo restoration, because the Earth has darkened by 2% this century. And so just getting it back to what it was 20, 25 years ago is a really important goal, and that's something that's a way of framing the question, and also showing the moral turpitude of the opponents.
Right. And did you say Sandy? This gentleman's name is Sandy Trust. That's his name.
Yes.
And he's on the HPAC meeting this Thursday.
Yes. And right. We're planned to. I think HPAC is usually at 10:30 p.m. for you in the UK.
Yeah, that's right.
I've suggested bringing it forward, and I haven't 100% confirmed that to 8:30 p.m. UK time.
That'd be a lot easier. Yeah, but then difficult for poor old Dennis Garrity in the Philippines. So.
Well, Dennis won't be able to attend because it's 3:30 a.m. Like there's no during your Northern Daylight Saving. There's no time that's suitable for everyone around the world.
Yeah. Okay.
Let's go to Sev, Anton.
Okay. Sev, please.
Right.
Actually, sorry, Sev.
Really
can we have Anton, because we haven't heard from Anton yet? Let's hear Anton's voice, only because to get the variety, and then we'll come back to you, Sev.
I just had a small comment, Robert. I like the work a lot. I think the best way to engage with the reinsurance industry is through hyper-analytical techno-economic analysis. The more numerical you can make your argument, the more they're going to be gravitationally pulled towards it. And so that's my only comment. Thanks.
Great. Thank you. Sev,
yeah,
please.
and that's been done in the series of reports, and the latest being Parasol Lost. But I think the underlying politics has meant that they're very tentative about the engagement. Thank you.
Mm-hmm.
What's really good about the reinsurance industry, if we manage to get them on side, is they have immense leverage on just about every other industry. Because if they say, for instance, to the real estate or the tourism or the big agricultural companies, that unless you come on board with this rebrightening thing, we're not going to reinsure you. And if you can't reinsure a business, or a property, you're dead in the water. You can't do anything. So they can, if they come aboard, they can simply ensure that everyone takes their fair part. Because if they don't, they simply get cut off from reinsurance. And if they're cut off from reinsurance, they're cut off from insurance, they're dead.
Well, the issue there of mortgages, that is that in order to obtain a mortgage, you generally need to have property insurance. And with the retreat of the insurance industry from regions that are at extreme risk of flood and fire, those important districts are becoming unmortgageable. And so there's leaving aside, Sev, the agenda that you've suggested of political pressure, there's just a straight up commercial issue. That is that places that are uninsurable, and it's quite right. Like, why would a bank give a mortgage to a place that's going to face intense risk? Like, you wouldn't insure Florida at the moment, in my view, because it's like with an insane government who insists that climate change is not real. It's like it then creates the political pressure on the insanity of the USA to get commercially real.
There are several island resorts in the Great Barrier Reef that are uninsurable, or they won't insure because of cyclone risk. They're blown away 2 or 3 times already. So if the insurance industry would say, well, you do ocean widening to protect the coral, well, then we'll insure you. I mean, it's a massive lever, apart from it being good for their business.
But it's a global issue, though. That this is part of the problem. Just the whole transition issue, because the idea of local protection is not feasible. There has to be a larger scale and longer term thinking, which is what people are generally not capable of. Greg's got his hand up.
Yep. Greg?
Thanks. Well, just on Sev's comment that if you can get the reinsurance industry on board, they influence everybody. But I mean, is the reinsurance industry speak with one voice? I mean, these insurance companies are competing with one another, and if you have to get everybody to agree to enforce this as a unified group, and that in capitalism that seems hard. Is that a problem?
Well, that's not the approach that I'm suggesting. What I'm suggesting.
Well, I was specifically talking about Sev's comment that that getting the reinsurance industry on board would give an enormous amount of leverage. But I was only commenting that I'm not sure that the industry as a whole is capable of a single voice, or a single action like that. What do you think about that, Sev? I guess
there are only about 4 or 5 big reinsurers in the world, so it's fairly easy to get 4 or 5 industries, 4 or 5 companies together to say we're going to do it. If you got Munich Re and Swiss Re together, that's almost enough in itself.
I see. Okay.
So both Munich Re and Swiss Re have significant climate analysis work, and on their websites there are extensive reports just detailing climate risk and damage. And this is where this figure of 100 billion climate. So total climate damage is now around 300 billion a year, of which around 100 is insured. So most is uninsured, which is a catastrophe for those who suffer from the damage. But if the insured risk is doubling every decade, but then if the companies say, well, we don't deal in decades, we only deal in years or quarters, then how do you change that thinking? And what's required in terms of a theory of change is for just something like $10 million a year to fund a public relations advocacy lobby work, which can then gradually mobilise a first mover coalition. I see Iceland and India as the leading candidates to advocate to establish an albedo accord on the model of the Montreal Protocol.
Yeah. As I mentioned here on their website, Solar Radiation Management, risks from reversing climate change. What if there was a shortcut through the Arctic? There we go. Yeah, so as you said, Robert, there's that was just looking up SRM. This might be worth a look. SwissRe.com.
About risk from having climate change.
Yeah, what about that? Yeah.
I mean, that sounds like a perverse incentive topic, right? The big problem is if we reverse climate change. If that's what it sounds like, then I don't know.
Well, at least they've thought about it. I think if you I've had people say if you do it too fast, then you get all kinds of nasty effects, possibly.
Well, there are massive risks involved in deploying albedo restoration technologies, and they need proper scientific management and governance, and that's completely absent at the moment. And so, like, people have identified all of these speculative concerns with no empirical basis, and largely based on the politics of defending subsidies to wind and solar. So that's the political context that we're working in, and it just needs to be all put onto a much more empirical framework. Hi, Brian. Nice to see you.
Likewise, yeah, and I'll second what you're saying. It's the old mantra of when in doubt, do nothing. But the burden needs to be transferred from those who would do nothing. We had a third of a century of delay and prevarication since the Rio Accord of 1992, and as a result, we're that much further down the road with no good solutions. I think the burden needs to be transferred over to those who would say, do nothing and watch the planet die slowly. And we need to actually foster the research and development that will constrain the uncertainties associated with climate repair that can start locally and go regionally and be led by communities wanting to be on the front lines of actually repairing our planet.
Yep. Thanks, Brian. Yeah, well said. Okay, let's move on. Thank you very much, Robert. Let's move
I see Jonathan has found my climate security timeline, which is a very provocative image. But
Jonathan,
a bit hard to...
Jonathan, can you just say something, Jonathan, so we see you?
Hey there.
Jonathan, are you there? There we
So
go.
I guess it'll become a larger screen if I talk a little bit, but yeah, you can also use the pin function by putting your cursor over the three dots near my square of imagery, and then do a pin, say PIN, and then it'll become as large as a slideshow to you on your screen.
Yeah, and one suggestion, Robert, and that is we might actually go with albedo restoration. Because just getting back to pre-industrial levels of marine cloud brightness and sea ice brightness would be a good initial step at level 0, let's say. And then at that point, we could assess what level of albedo enhancement might be needed. So
we had that conversation actually before you joined the call,
My
Brian,
apologies.
because it's 3 years. Like I proposed to Cambridge that they hold the workshop on albedo enhancement, which was 3 years ago, and I just commented that since then I've recognized that since the planet has darkened by 2% this century, just restoring the lost albedo is a key agenda. So you're exactly right, Brian. Albedo restoration.
Yep. Thanks, Jonathan. Did you put something in that you were talking about something I didn't really understand, but I don't want to go. Could you put a link in the chat? It sounded like something interesting. Put your mouse somewhere on your picture and it does something. Is there a link in the chat that we can play with?
Oh,
John
to reach
Cole?
this imagery?
Well, no, what he said was that if you go to the top right corner of anybody's screen and click on the three dots, there's a menu item which is pin. And if you click on that, then the person's screen will pin.
Oh, all right. Not on my screen, but anyway. All right. Let's have Anton before we run out of time. Anton, please. And what's it about? This is about
Yeah,
your.
I'm just going to give a quick update on something I've been working on that some folks in your group may want to jump in and help me with some various aspects. I'm going to reach out to a couple of you for sure. I've been studying phytoplankton production via artificial upwelling and nutrient dispersal for about 10 years now. I talk with a lot of scientists. I'm working with Exois. I've been working with them for about 2.5 years now. And about 2.5 months ago, I decided I wanted to make a new numerical model for ocean fertilization because I got hyperfixated on some model work that was done by some of the top marine scientists in ocean modeling, specifically Andreas Oschelys. And what I've discovered in all their efforts is that they use these giant Earth system models, which are just not granular enough to get into what I would call process engineering. So like, how would I today go out and do ocean fertilization? What is my method? What is my vessel? How much can I disperse over what area, depending on the season? All these variables that impact how you do that process. And with Claude Code and a few other knuckleheads willing to work with me, we've now got it to the spot where it's a highly complex model. I've shared it with Dr. Fei Chai, who's one of the top ocean modelers in the world, especially on the biologic carbon pump and ocean fertilization. And it's now turning into a project that we're doing with Xiamen University. And I'm going to be sort of releasing a staged process for individuals and groups to kind of kick the tires on it. I'd love to get Sev Clark's Buoyant Flakes built into it so we can look at different dispersal techniques and different time releases and different formulations for Buoyant Flakes. And yeah, so this is going to I'm going to become a bit of a noisy person over the next 6 months as this kind of pops up for input and other things. So I just wanted to give an update on that. And I guess actually a warning. I wanted to give a warning that there may be a little bit more Anton than you're used to, and maybe check to see if that's okay with your doctors. Okay.
Don't worry about it, Anton. Do you know this one? Where can you see? I can't see myself anymore.
Oh, there it goes.
Do you know this one? Yeah, that's it. So how do I get close to it? Anyway, so it's called this is Marine Carbon Biogeochemistry, a primer for Earth System Scientists by some guy in lots of people, but I thought it was Jack Middleburg, Burg. I think he's kind of Scandinavian, kind of from Netherlands or something like that. But there's lots of equations in it. I don't know if you can see these equations, but on pressure and sort of diffusion and things like that. But did you use this thing?
We're pulling from over 500 different literature sources and scientific sources. I'm sure that's somewhere in there.
Yeah,
that number is going to increase as more scientists get involved with it as a project. So yeah, I mean, we're not making up a lot of the only things we're making up is engineering specifications about potential new technologies and methods. Those are the only, because we don't have data on some of those things yet. So those are the only things we're speculating on. Everything else is pulled from peer-reviewed scientific literature.
Okay. Greg Slater, did you want to speak again?
Yeah, thanks. Anton, could you describe a little more closely the scope of your model? Just outline what it models in particular, because for someone not in your field.
Yeah, so one of the problem that I'm trying to solve is when you talk to marine scientists and they think, okay, well, we're going to go out on a boat, we're going to do a bunch of ocean iron fertilization, we're going to release a bunch of stuff, and then they're going to just try to measure the amount being sequestered down to whatever depth reaches the 100-year time horizon. That's about as far as they get into understanding the process. And then when you talk to lay people, I won't name names. I think we all know the names of these people who think it's a silver bullet. They're off by a massive amount. And then you talk to marine scientists who are really big opponents of ocean fertilization because they listen to model studies, and I'm going to give the exact example where they've modeled ocean fertilization happening everywhere south of the 38th parallel, every minute of every day for 100 years. That's 90 million square kilometers. You couldn't do even 5% of that. There's no logistical way you could do that through any means possible. And so, like, I'm building a model that's right now specifically about the Gulf of Alaska, but we're going to turn that into other locations where the Southern Ocean and other places are modeled for their biogeochemical conditions and surface currents, subsurface currents, weather conditions, all the other possible ways that can affect the outcome of an ocean fertilization event. So really what we're doing is we're getting hyper granular and then building that out to a regional size versus starting with these giant Earth system models that you can't get very granular on, but you can do long big Monte Carlo studies. But none of that is reflective of what actually is going to happen in ocean fertilization. So none of those models are actually functionally useful, in my opinion, as an engineer, because they don't represent the actual act of fertilizing in ways that are granular enough to tell you what is realistically plausible. So that's I'm trying to fill a gap. Essentially, I think I am filling a gap, and my team is filling a gap in sort of the modeling space where they're just using the wrong models to understand the full context of ocean fertilization at the granular level. Does that make any more sense, or did I just kick myself in the
That's a help. I can certainly understand the limitations of a global model just from the resolution problem, and de-resolving a global model is almost, it's probably not the way to go. You're building from the local outward, it sounds like.
Yeah, exactly.
And that sounds long overdue, although I'm not in the field, so I don't know. I'm just taking your word. But just about the methods, ocean fertilization is still, because I haven't done enough homework and reading, I'm involved in other things, but it still seems like an umbrella of a lot of different things, which could be quite different in the details. And you mentioned you'd be interested in including some of Seb's techniques, and then there's all kinds of other techniques. So your model is the way you see it evolving is to be able to swap those in and out, or even perhaps use them as a complementary fashion, perhaps. Is that something that your model hopes to do or is able to do?
Exactly. Yeah, no, you hit it right on the head. From everything from formulation type, which right now we've got 21 different formulations, to how you disperse it, to where you disperse it, to how much you disperse over what size of an area, at what time of year. And then, there's so many other variables to this whole, like what equipment do you use for MRV? So there's like different programmatic options for the MRV and how much does that cost? So the whole thing is turning into a techno-economic analysis based on the simulation of what you've decided and picked from the option list in the scenario input form that we've built. So it is really like you could sit somebody down and have them just answer the questions. So basically fill out the form and have it run the simulation and get them to realize, oh, this is way more complicated than I originally thought, because there's a lot of people running around saying, "Oh, we're just going to go out on a boat and we're going to solve climate change in 30 years," and they don't realize all the biogeochemical conditions, all the trophic activity, all the subsurface currents and surface currents and weather conditions that all affect the end game result based on how you go do and perform ocean fertilization. So I'm hoping to bring some engineering realism to the process in a way that should be hopefully a little bit entertaining. I don't know, maybe.
Yeah, I mean, I'm very interested in the approach you're taking. I mean, I'm I'm actually interested in backing SAI, which I could imagine you might be all against, but in any case, I believe there's a similar problem in realistic and the actual realistic application of it, which might allow for more of a control system. Now, I don't know if you're really working toward a control system for a larger scale control system to drive the introduction of these techniques in either complementary or even for a single one, but with different non-uniform application. But see, that seems to be a hugely missing thing across the board in geoengineering techniques. One other thing I just want to understand, now in the ocean fertilization, is this all about carbon capture, or is this also about albedo in your model?
We are going to count, so we haven't built this portion of it yet, but we've got it in the plan to build an ecological impact assessment based on it, which in that we've included DMS production, so we can look at, hey, what is the probability that DMS might help with cloud formation and cloud nucleation? Based on Seb's response earlier to my question, we don't have any phytoplankton size and spatial based reflectivity just on the biomass itself. So that's now something I wrote that down to look into that and maybe include that. So I think there's some albedo impact potential, but we can't say that's a claim, but we can say speculatively it could help in a way, but we probably won't be able to say, oh yeah, you've created some large volumetric amount of clouds. That's probably not where we'll go with it.
Okay. I would just say that I'm very interested in your methodology in this model. I don't know if you can share like an outline of it or anything like that, but whatever you can share, I'm interested in being able to check out. So,
yeah.
Maybe I'll email you separately. Thank you.
Sounds good.
Yeah. Thanks, Greg. Yeah, Robert, please.
Anton, you mentioned Andreas Oschleis. And I had some interesting contact with him a couple of years ago, and read his papers on nutrient robbing, and I found that a fascinating agenda, because it seemed to me that Andreas was presenting a quite political argument in the guise of a scientific argument, in the sense that he was saying that because there are models that say after 1,000 years the impact of iron fertilization would be to reduce the nutrients available in some high nutrient locations in the ocean. Therefore, the whole technology should just be banned. That was the takeout that I took from Andreas, which I thought was a very tendentious argument.
I agree, Robert. There are some people who build models and do model studies starting with a biased agenda. Some of these people, their heart's in the right place, but they really want to have everyone just focus on decarbonization. That's not going to work. I think all of us on this call recognize that's not going to work. You have to do the climate triad in order to really effectively deal with this. So those sort of like 10-year-old model studies that he's done, I don't think they are aging well, is my guess. I've never talked to him, but I'm told he's a really nice guy and he's obviously very accomplished. But I chalk it up to two things. In fact, recently I got talked out of a more aggressive stance, but I chalk it up to two things. One, earlier understandings, 10 years ago or even older, understandings of the actual problem of climate change, which back then a lot of people thought, oh, we just need to decarbonize. Today, we know it's much more than that. And number two, the limitations in the tools being used for modeling and the granularity in process that actually is the whole reason I'm doing this new model. So I have a much softer tone about modelers that go after or have a historical record of trying to muddy the water for their political agenda of decarbonization alone. So I no longer have a lot of ire around that, even though I'm a quite pugnacious of an individual. But yes, I agree with you. I think there's a bit of a prior agenda with a lot of those studies.
Yeah, like the first thing you said, which sounded to me like, well, if you hit something with a sledgehammer, you might damage it. That's what it sounded like. Yeah, if you hit something with a sledgehammer, it might get hurt. So, well, don't hit it with a sledgehammer. And you're saying, because they were saying, if you did this much ocean fertilization, it would cause a problem. Well, don't do that much then. And you couldn't do that much anyway.
Exactly.
But then there's also the question that you raised, Anton, of upwelling, and so the whole issue around the technology for upwelling and just obtaining the vast quantity of nutrients that are available in the deep ocean. To me, I mean, my view is that when you consider that there's 1 billion cubic kilometers of water just below 500 meters or whatever level is the thermocline, which is just chock full of nitrates and phosphates and all manner of valuable commodities. And so I've I'm not an engineer or a scientist, I have a philosophy background and international development background, but I've developed a number of invention concepts for upwelling and using tide and wave energy. And so I'm very interested in. I won a prize for an invention on that from MIT. So I'm very interested to explore whether the feasibility and testing of upwelling technologies, because to me that's really key, and also Brian's interest in his tensegrity seaweed model is Brian found that for macroalgae production that sinking the macroalgae is more efficient than raising the nutrients. So there are such interesting technology issues in this whole space.
Yeah, agreed. I would just caution, can we really trust Brian though? I mean, seriously. Sorry, just mess with you, Brian.
You're just trying to be pugnacious, aren't you? Right, we haven't got much time left. Sev and John, please.
On the nutrient robbing question, it seems really curious to me that with my buoyant flakes, which are adding 3 nutrients to the ocean, how can you possibly say that that is robbing the ocean of nutrients? You're adding them. It doesn't make sense.
Oh, they'll use up something else. Sorry, go on, Anton.
Yeah. I mean, I think that part of the purpose of the model that we're working on is to show the very minimal amount of actual nutrient robbing based on realistic scenarios. As Robert said, the depth of the ocean is full of nutrients going down to about 1,000 meters with varying amounts at different depths. And so when you just build, when you produce phytoplankton at the surface, you're taking off a single epidermal layer of nutrients. And even that, you're not really taking it off. You're just recycling it through a gradient as it sinks and part of it remineralizes. So yeah, nutrient robbing is not something I'm concerned about in any context other than if water directly flows into a biodiversity hotspot or a known non-transient fishery. So those are the areas where I think it has some legitimacy to be monitored.
Yep.
Why,
Right.
why do you say 1,000 meters? Like the ocean depth is average 4,000 meters. And
Yeah,
I understand. Go on.
it gets less nutrients the further down you go.
Okay.
Well, that's actually not correct. The nutrients increase roughly linearly up to 1,000 meters depth, and then they maintain, at least the macronutrients, nitrate and phosphate, maintain their high level down to the bathypelagic zone.
Really?
So,
I did not know that.
yeah, so it's
Are you
a
sure?
ramp.
Are you
It's
sure?
a
Or are you just
quasi.
saying that because I tried to slam you earlier?
That's
Well,
my
I,
understanding. I've seen there are some really interesting charts, Anton, of nutrient density by depth, which corroborate what Brian's just said.
Cool.
Yeah.
Love to see that. Thank
Now
you.
you know the reason you came here, Anton. Yeah. John, please.
In certain areas of the ocean, there was biosurfactants, nutrients on the surface that can be extracted by ships just steaming along doing their normal business without affecting drag, things very deep down that we looked at a few years ago. So there is an option even on the surface in certain areas to extract a number of nutrients as well.
And there is a basis for nutrient robbing in the epipelagic zone, that is the top 100 meters. And it depends on the region, but downstream ecosystems, in many cases, the phosphate ultimately gets drawn to zero. So you have to track the phosphate. And that is, energetically separated from the mesopelagic zone down to 1,000 meters and the bathypelagic zone. And so the nutrient reservoirs are quite separated. And of course, there are some places like off the Pacific coast of Canada where the upwelling occurs, from the deep water. And that's where you do get new nutrients from the mesopelagic zone, but you also get the challenges of ocean acidification, which are really challenging the shellfish hatcheries there. And so you end up needing to do macroalgae cultivation upstream of the shellfish in order to get the pH up high enough so the shellfish can survive. So there's a few zones like that. So I think there's places where we got to pay attention, like you were saying, Anton, to nutrient robbing. But when we go straight down to the mesopelagic zone to get our nutrients, then you've got a huge supply, thousands of years of supply, and of course it's always being refreshed from the bathypelagic zone.
Cool.
Below 1,000
Right.
meters.
All right, I've just got one question, Anton, because I mean, based on most of the extra heat coming to the Earth comes in at the tropics, at the low latitudes. I mean, this is most heat comes in there anyway, and I keep saying the same thing every time, and it mostly leaves in the temperate zones, and it's nearly all gone by the time you get to the polar regions, and it gets carried by latent heat in the air in these cyclones. It's never just a wind; it's circulating, as we know. So, and also at the tropics, this is where you have got the worst stratification. So you've got the largest loss of nutrients. I mean, it's pretty oligotropic anyway. There isn't much anyway, because of the stratification that's natural, that was always there. But if you don't have much biology to move it around, then it just ends up completely stratified, almost completely stratified. So this is what would be most interesting to me, is if there are experiments done where it should be cheapest and most pleasant, where it's nice and warm, in the tropics and subtropics. And this is where I believe this is where the largest loss of albedo is as well, where the clouds are dimming the most. So this is where you could actually provide the most cooling by increasing cloud cover, and where you can say you're restoring cloud cover, and it should be the cheapest area, because the seas, I mean, for the Pacific is most called the Pacific because it's peaceful. There isn't much. It's generally less rough seas in the Pacific. So that's what I'd be interested in. If you have plans to fertilize in the tropics.
In the model, we are hoping to have mid-latitude waters, at least one or two locations built in by October this year, before we go to the modeling workshop. So I don't know what that will look like yet, and I don't know where those selections would be, but it would be based off of what probably people like Seth John or Tony Michaels or Fei Chai would recommend. So more info on that.
Great. Okay, one last thing. So you said you're going to be active on the email group in the next 6 months, but you don't want to be doing it all on your own, do you? I mean, do you have a call to action, or is there anything you'd like people to do, or a request for people to do something?
Yeah, I mean, I'll be releasing some information about the model itself being as it's developing, but also pulling different people in to help kind of guide specifications for different aspects. It could be some form of new artificial upwelling device. It could be some formulation like buoyant flakes. So we'll want to build in a more optionality into the model based on what people are actually doing, so they can find the model useful, so they can run scenarios with their tool or their formulation or whatever, and then look at how that functions and what the play out is.
Great. So that's what we can expect down the line then.
This will I'll be far more active over the next few months leading up. The whole thing has to be at least launchable by early October. So that's our deadline.
What is the modeling workshop you referred to? I'm sorry.
There's a ocean fertilization modeling workshop happening in Xiamen University in October.
Okay.
And so that's our deadline.
Okay.
For at least a healthy launch of multiple places around the world, not just Gulf of Alaska. After that, we'll build in like ocean alkalinity enhancement and some other additional ocean-based techniques. So it'll grow beyond ocean fertilization.
Okay, thank you.
All right. Okay, so much more we could all say. Thank you very much, Anton. Thanks, everyone. We've had our more than an hour and a half, and so see you again 2 weeks. This is the public one. This is going to be submitted publicly to YouTube. See you soon.
Thank you.
Sure.
No.
Bye.
Bye
Thank
all.
you, everyone. See you soon.
See you soon, Ursula.
Bye. Thank
Bye.
you. Bye.
John, are you still there? No. Okay.